Yes, class, good evening. So I'll start with thermodynamics today. So in your thermal physics, only this lesson is left. Kinetic theory and thermal physics, we did, thermal properties we did. So I think you're having a test also for the same. So now thermodynamics, what is thermodynamics? It basically deals with two quantities. One that you all have studied in your thermal properties of matter, that is heat, and one is work done, that you have studied in work, energy, and power. So two quantities that we have studied, heat and work. Whatever is the correlationship between heat and work, this is given by the branch of physics which we call as thermodynamics. All right. Why? Because thermo means heat and dynamics means motion, work done will come. So that's why this deals with thermodynamics. Now there are few terms which you have to understand. What is meant by system and what is meant by surrounding. These two terms, I think you have it in your chemistry also. If you've done states of matter, system, surrounding, isolated system, and all is there. I'll repeat it. Wherever you have doubts, please let me know. See, system and surrounding is what? For example, if I'm saying I am wherever you are experimenting, no, or whichever area is under your observation, that you will say that is your system. And anything apart from that, you call it as surrounding. For example, if I say, if I am, let's say I have having this glass of water, I am just focusing on this glass of water, whatever forces, let's say this is the glass of water. So I'll say, let's say mg downwards, gravitational forces acting, normal reaction is occurring, then water molecules are exerting kinetic energy, potential energy, and everything that is related with this glass of water. Fine. A big example is, let's say, a glass of water. All right. Now what will happen? Apart from this, a table must have been there on which the glass has been kept, right? Other than this glass, whatever in this universe exists, I'll call that surrounding. So for me presently, just this part is my system, because this is the area under observation for me, and anything else from apart from this glass of water will become the entire surrounding for me. Anything that will be included, whether you go out of earth, moon, stars, all the celestial objects, anything. So anything apart from this, that becomes the surrounding. All right. So glass of water is known as, this is your system currently. For example, if car is moving, right, and you are just considering and calculating the velocity of that car. So the velocity of that car is, the car is currently system for you. Anything apart from the car, whether it's another car that is moving, that will be considered in surrounding. So part of universe that is under the thermodynamical consideration, you are dealing with properties like pressure, volume, temperature, that part of system or that part of the entire universe, that is known as system. And rest of it, everything outside the system which can have a direct impact on the system, we call it as a surrounding. Now see, surrounding is everything that is apart from the system. So system is dynamic for us. We have to study system in detail, because we are not concerned with surrounding. So see, systems are of three types. Because in your questions, this won't be asked to you directly in the exam to write about system and surrounding or mention the types of the systems. But in your exam, in your numericals, directly a question will be saying like, a closed system consists of this much pressure, like this. So you have to understand the meaning of all these. So systems are of three types. Systems are of three types. Systems means what? Part under thermodynamical consideration, or whichever observation part is there, where you are calculating pressure, volume, temperature, anything. That is your system. It can be open, it can be closed, it can be insulated. Fine, open, closed, insulated. Now open system means heat exchange or matter exchange, proper exchange of heat and matter, they are allowed in open system. Fine. So in open system, you have exchange of matter or heat. Now exchange with what? For example, if some of the molecules which are very hot, these are losing heat to the environment and these are becoming cold. For example, if you take a glass of water and the water is very hot and you keep it aside on a table, after some time you will observe that the temperature has decreased, right? It's not so hot. So what does it mean? That it must have loosened some of its energy outside to the surrounding. So a system which allows these phenomena, which allows the exchange of matter or heat, that we call as open system. Heat with the surrounding. Fine. So what is a closed system? In your closed system, only heat is exchanged. Only heat is allowed to be exchanged. Matter cannot be exchanged. So this closed systems exchange only heat. And what is an insulated system? There is neither exchange of matter nor exchange of heat. So neither exchange of matter nor heat. We actually call this as adiabatic system also. For example, you can take the example of thermos that we have. There is no exchange of heat or matter. Whatever content is present within the thermos, that remains insulated. So we also call this as insulated or adiabatic. So this is the introductory part of it. Don't write law of just simply write thermodynamics. Laws I'll state later. All right. Note this part down, then I'll discuss this further. This is a very basic part. Nobody's going to ask you to write the definition of all these. It's just that you should know the meanings of all the systems, meaning of systems and meaning of surroundings. Okay, so everything outside the system which can have a direct impact. So that means, now see, your system plus your surrounding, whatever is left, this only in total makes your entire universe. Fine. Now, thermodynamic parameters, these are the physical quantities that define the system and help to understand the behavior of the system. So what are the thermodynamic parameters? We'll talk about pressure, volume is there, temperature, then internal energy, force, all these. But what are the main parameters that we'll be considering? Pressure, volume, temperature. That's why we had studied these in kinetic theory, right? Now, equation of state is what? It's a relation between the thermodynamical parameters. For example, if I write this equation, PV is equal to nRT. So this is a relationship between what? Pressure, volume, temperature. This is pressure, this is volume, and this is temperature. So it's a relation between these three parameters. So equation of state can be any equation, wherever two thermodynamical parameters will be relating with each other. Any equation where any constant can be there, any other variable can be there, but it should have thermodynamic parameter. Now, what is meant by thermal equilibrium? See, for thermal equilibrium, no, see, here we take two bodies are in thermal equilibrium if they have the same temperature. So this thermal equilibrium we did earlier as well in thermal properties when we were doing. It means this is one container A, this is another container B. When both the temperatures are equal, we say this is thermal equilibrium, right? This we have studied. But what is thermodynamical equilibrium? This is something different. Thermal equilibrium we did. Thermal equilibrium was when two temperatures are same, and temperature is one of the parameters, one of the thermodynamical parameters. If your all the thermodynamical parameters are constant, they are not changing with time, then you say thermodynamical equilibrium. If only temperature is remaining constant, or two cups are there, let's say they are having the same temperature, or two containers are there, they are having the same temperature, you will say they are in thermal equilibrium. If they are having the same pressure, same volume, same temperature, then only you will say these are called as thermodynamical equilibrium. So now, so it means thermal equilibrium is a part of thermodynamical equilibrium, right? Because your temperature is one of the thermodynamical parameter. So it means if it is one of the thermodynamical parameters, so it means one thermal equilibrium is one type of thermodynamical equilibrium. It can be mechanical equilibrium also, where pressure is same, volume is same. It can be chemical equilibrium also, where internal energies remain same. So thermodynamical equilibrium means in totality, the system is in equilibrium with all the thermodynamical variables, or which variables which are constant currently. And thermal equilibrium, which we studied in thermal properties of matter, this means that two bodies are in thermal equilibrium only if they have the same temperature. So just same temperature, thermal, all thermodynamical variables in thermodynamical equilibrium. So I'll start with zeroth law. Tarif, you were asking also about zeroth law. So do one thing, note down all these points. These are very small points. This will not take you so much time. Then I'll start with zeroth law. You have all the laws, first law, second law. I'll do all these. So we'll start with zeroth law. It's very easy. Zeroth law will just take 5 minutes. Quickly note down all these points. Now see what is meant by zeroth law. So zeroth law is very easy. Just consider this example. This is the system under the consideration, this yellow boundary. This orange line that is drawn, no, this orange line. Let's say this is isothermal wall. Let's say this is isothermal wall. So what is meant by isothermal wall? That it is conducting wall. This is conducting wall. Conducting wall means it will allow heat to be exchanged. This allows heat to be exchanged. Means heat exchange can take place here and it can take place here from A to B and A to C, because this wall is allowing. But this is adiabatic wall. This means this is a non-conducting wall. There won't be any heat transfer from B to C. Now what? Let's say temperature of A and C are equal. TA is equal to TC. Fine. Temperature of A is equal to temperature of C. All right. And temperature of A is also equal to temperature of B. Why? Because both will become in thermal equilibrium as the wall is conducting. Here also heat exchange will occur. Here also heat exchange will occur. But they are not allowing the heat exchange to occur because of the adiabatic wall. So temperature of B and C should never be constant, should never be equal. But since they are in equilibrium with the third body, they will also be, by the calculation also, if TA is equal to TC and TA is equal to TB, then TC is equal to TB. That is simply what is meant by zeroth law. Two bodies or systems that are in thermal equilibrium with the third body are in thermal equilibrium with each other as well. They were equilibrium with the third body, that was A. Right. Now they are also in equilibrium with each other. That is what is meant by it. Before we start with the work done, no, just a small concept of internal energy that we have already studied. It's just that I'm revising you. In your internal energy, entire kinetic energy, entire potential energy of the system comes. Just a small reminder which we did in kinetic theory class. It was that for ideal system, ideal particles, for ideal potential energy becomes zero. So only we talk about kinetic energy. Just a small revision. Now we'll properly start with work done. Quickly note these points down. Zeroth law. Then we'll start with work done. It is entirely different topic. Based on whatever you studied, basics of work done, but this will be modified in terms of heat. See, Tari, for today's mock test, no, whatever you have studied till the previous class, we did kinetic theory, right? And we did thermal properties. So thermal properties of matter, the lesson which we did earlier, thermometer, temperature equal, that lesson, and kinetic theory, which we did in the last class. These two will come. Thermodynamics, it will come in the next test. This, since your class was missed on Monday, no, we couldn't have a class on Monday. That is the class which I'm taking. Now you'll be having a regular class. Next class will be on Monday. We'll continue with thermodynamics. So oscillation waves, these will be after thermodynamics whenever we'll complete next week or next to next week. See class, now what is work done? So here in thermodynamics, we'll talk work done related to change in volume. See, you have initial volume. Let's say V1, this is the initial volume. Volume of the container of the system changes to V2. So this is final volume. Fine. Let's say P is the pressure of the system. Pressure that is exerted on the system is P. And this pressure is remaining constant. Fine. So what is work done? Work done is basically the product of the constant pressure multiplied by the change in volume. This is what is meant by work done. This is pressure. This is change in volume. All right, so if V2 was the final volume, V1 was the initial volume. So how will we write work done? We'll write it as P multiplied by V2 minus V1. That's how we'll write this. But this is when your pressure is constant. If let's say pressure is variable, then what we are going to do? Then you cannot use this. Then you will simply integrate pressure with respect to volume from V1 to V2. This is the formula for work done when pressure is variable. This is when pressure is constant. All right. For example, let's see some questions. See, pressure of a gas is 10 pascals. This is the pressure given. Pressure is given as 10 pascals. Its volume changes from 5 meter cube to 25 meter cube. You have to calculate the work done. So initial volume is 5 meter cube. Final volume is 25 meter cube, right? So what is the change in volume? 25 minus 5, that is 20 meter cube. So work done is pressure multiplied by change in volume. Pressure is 10 and change in volume is 20. So your answer is 200 joules. That's how we write. And what if it is variable? How to use the second formula? Understood the usage of the first formula, P delta V. Like this only you have to use. And let me tell you the usage of the second one, if P is variable. See, if pressure is variable, let's say pressure varies as 3V. And I have to integrate it from 1 meter cube to final V2 is 3 meter cube. So now this is variable. Pressure is depending on this variable V. That's how you are identifying. How will you identify whether your pressure is constant or changing? If like in the previous question, it was 10 pascals. Whatever you change in the surrounding, 10 pascals will remain same. So it means pressure was constant. We used P delta V. Here it is saying it varies with volume as 3V. It means if V is 1, pressure will be 3. If V is 2, your pressure will become 6. If V is 3, pressure will become 9. Pressure is variable. So here this is a hint that we have to perform integration. So what's the formula? P dV integrating from V1 to V2. So what is the value of P? P is 3V. So 3V dV V1 to, I'll not write V1 to V2. What is the value of V1 and V2? From 1 to 3. From 1 to 3, I have to integrate this. So how do we perform integration class? 3 is a constant. Now V, look here class, all those who have forgotten integration, V to the power n is there. If any variable x to the power n is there, what do? We plus 1 here. So it means V is here. Power is 1 only. No power is given, so it means power is 1. What do you have to do? Plus 1. And write this entire term n plus 1 in the denominator. It means write this in the denominator 1 plus 1. Fine. And what are the limits from 1 to 3? This means this becomes 3 by 2v square, right? 1 plus 1 is 2. V to the power 1 plus 1 is v square, integrating it from 1 to 3. Now keep 3 by 2 aside. Put value of upper limit first instead of v. Put 3 square first minus. Now put lower limit 1 square. So what are we left with, class? 3 by 2 into 3 square is 9 and this is 1 square is 1. So that means 3 into 2 by 8. So 2 into 4, that becomes 12. This is the work done. Class, tell me, is work done part clear to all of you? Is it clear? Any doubt still here how to use whichever part? Hiba, Tarif, Abdullah, Waziha, clear to all of you?
Yes, miss.
What about others apart from Tarif? Only Tarif has understood. All right. Note it down wherever you will get stuck up. No, you can ask me because this is very basic part for your thermodynamics. Get it cleared? Now look class, PV diagram means graph of pressure and volume. So see, graph of pressure volume, if you calculate the area under the PV diagram, you get the work done. Fine, graph is plotted between pressure and volume. From kinetic theory, we know according to Boyle's law, the graph between pressure and volume is this. So whatever is the area enclosed, this area that is getting enclosed, this area that is getting enclosed, this is given by, this gives you work done. So area under PV diagram is area under PV diagram. This is work done. So see, whenever your container or the molecules expand, your work done will always be positive. And whenever compression occurs, work done becomes negative. Fine. Or even if you are given a graph, right, and the work done is, you are seeing it is clockwise, so directly assume for clockwise work done will be positive, and for anti-clockwise work done will become negative. These are certain rules of it. Now simply you just have to find out the area. For example, I tell you this question. This is the question given to you. This is the graph that is given. Pressure, volume, this is the graph that is given to you. You have to find out work done. So obviously it's a triangle. So what is the area under the graph? How do you calculate the area of the triangle? Half into base into height. Base is 10. Height is 5. So that becomes 25 joules. Fine. This is cyclic process. I'll tell you, first note it down. Then I'll tell you last topic is cyclic process. Note it down. Now see class, if you have cyclic process, so cyclic process is a process in which initial point and final point remains the same. Let's say from A you're starting, from A to B the body is moving. Now from B again back to A it will move. So this is what will be the graph that you will get. P versus B. So cyclic processes, initial point is also same and final point is same. Fine. This is what is meant by cyclic process. So let's say if you have to calculate the work done here. So again, you just have to find out the area of the shaded region. Area of the shaded region. So that will be length into breadth because it's a rectangle. So it will be 200 joules. Note it down class. Cyclic process. No, Hiba. See, in cyclic process graphs, it's not necessary that they are angled at 90 degrees, but it should be a closed figure. If you are observing that it's a complete closed figure, then it definitely means it is a cyclic process. Like the question, no, which I have given you, this graph part, here, no, actually the arrows are missed because of this square. These arrows are depicting that it is reaching its initial point back. Whereas if you see the triangle question, see here only one arrow is there. It's starting from this point, ending to this point. There is no turning back or reaching the same point. So it means it's open, and cyclic is closed. So you can see from the graph also, it is returning. Actually, there's an arrow here also. It is showing it is going back to its original position. So just don't go by the figure. It should be closed and it should have same initial and starting point. So note it till here, class, and then where whoever gets it completed, you can then leave. This is all for today. We'll continue on Monday properly then. See, Tarif, in this question, you have to find out work done. And how, what did I tell you how to find out work done? Work done is found by taking the area under the graph. So what is the area enclosed? This is a rectangle, 20 and 10. So it's a rectangle. So what is the area of this figure? Just multiplying length into breadth. So length is 20, breadth is 10. So 20 into 10, that is 200 joules. These arrows are just depicting that it is a cyclic process because initial and final points are getting repeated. That's it. Understood?
Yes, miss.